Hi everyone, welcome back to Teaching Math. Have you ever seen a number with so many zeros it made your head spin? Scientists and engineers don't write all those zeros. They use scientific notations instead. So let's explore and learn what scientific notation means, how to convert from standard to scientific notation, and how to convert from scientific notation to standard form. Let's get started. Well, when do we use scientific notations? Imagine if you want to measure the distance from Earth to a distant star in meters. That's something like 40 quadrillion. Very hard to read. So scientists instead use 4 times 10 to the 16th power. Similarly, for the size of the atom, since it's a very small number, they will use 1.23 times 10 to negative 10th power. So 40 quadrillion is a number that we already know. We use much like 1, 2, 3, or 50, or 100, 1000. Those are the numbers that are written in a standard notation. And we convert those big and small numbers to scientific notation for ease of use and most simplest way of expressing those big numbers. Let's go ahead and get started and learn how to convert between standard notation to scientific notation. Let's get started. So what is scientific notation? Well, as we learned from before, scientific notation is a way to write very large and very small numbers, and the way we write it is a simple product. The coefficient will be between 1 and 10 and can be decimal, and that coefficient will be multiplied by 10 raised to a power as an exponent. So here, what we're saying is that a is our coefficient, and it is multiplied by 10, and then it is raised by a power of n. And if you notice before, the powers were negative when it was a number greater than 1, and positive. So from our previous examples, you've noticed that one of them was raised to 16th power, and then the other one was raised to negative 10th power, saying that this is a number that is less than 1. Let's go ahead and look at some examples and see how we're going to convert a number that is so large, like 40 quadrillion, into 4 times 10 to the 16th power, and where does the 16 come from? Here's our first example, 5,300,000, and I've made the point to write our example here, the formula, how are we going to use it, and our first step will be move the decimal, because we're looking for a number that's between 1 and 10. Okay, and I want you to notice one thing. When we're moving the decimal, it cannot be 10, so I'm going to write that a must be less than 10, and it has to be greater or equal to 1. So this is a very important distinction, that when we're trying to move the decimal, we have to move the decimal as many times as it takes until the number is less than 10 and equal or greater than 1. So let's go ahead and do that with our first example. All right, so our first example, we're going to start moving the decimal. Obviously, because this is a number greater than 1, and it's a whole number, the decimal will be all the way at the end. Our first step is move the decimal. Now, because this is a number greater than 1, we're going to move the decimal towards left. So I'm going to write here left. We're moving it towards left. 1, 2, 3, 4, 5, 6. Now, I'm moving the decimal as many times as it takes, because until I get a number that's less than 10. 5.3 is less than 10, so I'm okay to write that number 5.3. And then I'm going to multiply that by 10, and then think about, well, how many times did I move the decimal? I moved it 6 times, and I'm going to write 6 in here. So in theory, what we're saying is that those two numbers are equal to each other. We just changed the form. So if you really think about it, when I was moving those decimals, I was dividing each time by 10. And as you divide by 10, you're moving the decimal. But since I have to write equivalent expression on the other side, it has to equal to 5,300,000. I have to multiply by the same amount of tens. And if we know from the exponents that exponents show repeated multiplication. So our step 2, as you noticed here, was to multiply our coefficient by 10 and raise to power of 6. Let's erase this and try our second example. Okay, I'm not going to erase the move the decimal because we are still going to do exactly the same thing. So our second example is 0.000, one more 0, 42. Okay, again, our first step will be move the decimal, and what we're looking for is the number is going to be, the A is going to be less than 10, and it's going to be greater than or equal to 1. So I'm going to move the decimal as many times as it takes until I reach a number that is less than 10 and greater than or equal to 1. So 1. Notice that I'm moving towards right. Okay, because this is a number that is less than 1. 1, 2, 3, 4, 5. Okay, so we moved it 5 times. We got our number 4.2. And remember, those two numbers are equal to each other. 4.2. Then our second step will be multiply by 10. And then since we moved it 5 times, I'm going to write 5. But there is something missing. Since this was a number that is less than 1, we have to write negative 5. So let's go ahead and restate what was our second step. So step 2 will be multiplying, right? Again, it's the same thing, by 10 raised power of 5, negative 5. Let's go ahead and do the next examples. Okay, so again, we're going to follow up with our steps is moving the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, when I reach here, I know that that is a number less than 10, so I'm going to rewrite that number 9 times 10, and I move the decimal 10 times, so that will be to the 10th power. Again, we move towards left, okay, because this was a number greater than 1. Let's go ahead and do the next example. This is the number less than 1. That means that I have to move the decimal towards right. And I do have that in the back of my mind that my exponent is going to be negative. Let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So a lot of students make an error here and go one more further. But when I look at this number, 6.78, that tells me that this is a number less than 10, and that's exactly what I'm looking for. So I don't need to do anything different except write 6.78, and the fact that I moved it 10 times, so 10 to negative 10th power. All right, so let's recap on converting from standard to scientific notation. The step one will be us moving the decimal towards left if the number is greater than 1, and we're looking for a number that is less than 10, greater or equal to 1 as we move our decimal. And we move the decimal point towards right if a number is less than 1, and we move it again to as many times as it takes until our coefficient is less than 10 and greater or equal to 1. Again, we will write a negative exponent when the number is less than 1 and positive exponent when the number is less than 10. Now let's talk about how to convert from scientific notation to standard form. Before I convert it back to standard form, what I'm looking for to see if is my exponent negative or positive. In this case, it is positive, and that means that this is a number that's greater than 1. So when we were converting from standard to scientific notation, we were moving left, as you remember. Now, to undo what was done before, we have to move the decimal point towards right. So we're undoing and going towards right because this is a number that's greater than 1, and our exponent is showing that. To create equivalent expression, we have to move the decimal point towards right. And the exponent of 5 is telling us how many times? 5 times. Let's go ahead and do that. 1, 2, 3, 4, 5. And the fact that we moved it 5 times, that means we are multiplying by 10 times 10 times 10, 5 times. And so that will be 0, 0, and 0 in here. And here's our number. I'm going to rewrite that. All right, so we did find our equivalent expression. And if you really want to know like what happened, I can expand the power of 10 and say that 4.57 is multiplied by 10 and another 10 and another 10 and another 10. So 1, 2, 3, 4, and 5. So for you to understand, so each time we're multiplying by 10. So if I have to multiply this by 10, so it'll be 45.7, and then multiply by 10 again, that number will be 457, and then multiply by 10 again. And this can keep on going until you reach your number, and then multiply by 10 again. One more 0, adding, and then the last but not least, 1, 2, 3, and the number is 457,000. Also, you would know that it's 457,000 because 100,000 has 5 zeros. Okay, let's go ahead and do the next example. Now I'm going to examine the number, and I can clearly see that this has a negative exponent of 4, and that just tells me that this is a number that is less than 1. And if you remember, when we had it in a standard form, a number that was less than 1, we moved the decimal towards right. So when we're undoing what was done before, we have to move it towards left. Here's the thing. And how many times do we move it? Our exponent is telling us that 4 times. Let's go ahead and do that. So I'm going to rewrite the 6.2 in here, and then move the decimal 1, 2, 3, and 4. And I'm going to put the decimal here and write all of my zeros in there. And so you can see that this number, again, I'm going to rewrite everything so you can see, is equal to 0.00062. And so you can clearly see those numbers are equivalent, and what happens here, it's a division that keeps going, and then as you divide a number by 10, you would be moving the decimal basically 5 times. So another way that I could have rewritten this is 6.2 times 1 over 10 to the 4th power. Yeah, and then this will give you an idea to what happened here. Are you ready to do an example on your own? Let's get started on that. All right, now that you know how to convert from scientific notation to standard form or standard to scientific notation, do it yourself, pause the video here and convert those numbers. First one is converting from scientific notation to standard form, and then second one from standard to scientific notation. Okay, welcome back. Let's convert the first one to standard form, and again we're going to work on this here, 3.56, and the exponent here is telling me how many times I have to move it. 5 times move the decimal. And where am I moving this? Towards right, because it is a number that is greater than 1. So go ahead and do that. 1, 2, 3, 4, and 5. Add the zeros. And here's our number. Let's rewrite that number here. Oh, okay, hopefully you got that one right. Let's go ahead and do the next one. Okay, so we're converting from standard to scientific notation. I'm going to move the decimal, so rewrite this number in the bottom. One, 2, 3, 4, 5, 6. I can't stop here because this is 91. Gotta move one more time. 7, 9.1. So again, I'm gonna write 9.1. Is this a number less than 10? Yes, it is. Multiplied by 10 and raised to, how many did we say? 1, 2, 3, 4, 5, 6, 7. To negative 7. Don't forget that negative exponent, because that will tell that the standard number was less than 1. All right, let's summarize what we learned. So we use scientific notations to express very large numbers and create equivalent expressions for it. When we're converting from standard to scientific notation, we move the decimal point right if the exponent is negative, and we move the decimal point towards left if the exponent is positive. And when we're converting back to standard form, we undo what was done before. We move the decimal point right if the exponent is positive, and then we move the decimal point left if the exponent is negative. You did such a great job staying all the way to the end. Pat on your back, because now you learned what is scientific notation and how to convert from standard to scientific notation and from scientific notation to standard form. In the next video, we will learn how to multiply and divide numbers in scientific notations. Thanks for watching Teaching Math. Remember, learning math takes patience, practice, and perseverance. See you next time.